Hi guys, now I'm going to solve the sixth question of the Math 104 Endsem examination. This is the last question. So here we go. The sixth question is, consider the ODE y double dash plus 16y is equals to 4 delta of t minus 3 pi and y of 0 is equals to 0, y dash of 0 is also equals to 0. So the part A, what kind of real life phenomena is captured by the delta function if the ODE represents a mass spring system? And part B, without solving and just using your intention, sketch the graph of the solution. And part C, solve the ODE and the sketch of graph of solution, compare the two graphs. So for the part A, so actually the force applied on the mass spring system is for a very short time, and the delta force represents the delta function representing the equation of motion during that time. So now we'll be looking to the second part. For the second part, we can use the properties of direct delta function, that is delta of t minus a is infinity at t is equals to 0 and 0 at t not equals to a. So infinity at t is equals to a. So given here a is equals to 3 pi. So we may say that the graph changing shapes at t is equals to 3 pi. For example, if we say the graph before 3 pi was varying, and it means it's a constant or varying, and it may change its period or shape or anything in the next 3 pi, after 3 pi. So like this maybe, so it would be like, it may be a sinusoidal, and then at after 3 pi it could change its period, shape, anything. So given y double dash plus 16y is equals to 4 delta t minus 3 pi, and y of 0 is equals to 0, y dash of 0 is equals to 0. So taking the Laplace of the whole equation, so here we are using the Laplace. So the Laplace of y double dash plus 16 Laplace of y plus 4 is equals to 4 the Laplace of delta function t minus 3 pi. Let this be equation 1. So the Laplace of y double dash is equals to a square Laplace y minus s y of 0 minus y dash of 0. That means Laplace of y double dash is equals to a square Laplace of y. And now we'll be doing the Laplace of delta of t minus 3 pi. So taking the Laplace of delta t minus 3 pi is equals to e to the power of 3 pi s, as Laplace of delta t minus a is equals to e to the power of minus s. This is the formula. Substituting this in the equation 1, we get a square Laplace y plus 16 Laplace of y is equals to 4 e to the power of minus 3 pi s. That's Laplace of y taking common is equals to a square plus 16 equals to 4 e to the power of minus 3 pi s. So the Laplace of y is equals to 4 e to the power of minus 3 pi s by s square plus 16. So y is equals to Laplace inverse of 4 e to the power of minus 3 pi by s square plus 16. So the Laplace inverse of this function is actually, see, 4 by s square plus 16 into e to the power of minus 3 pi s. Let this be the second equation. So the Laplace inverse of e to the power of minus as f of s is equals to f of t minus a into h of t minus a. So here h is the Heaves side reaction. So Heaves side function is actually, it has a jump of size 1 at t is equals to a. So we can define them as h of t minus a is equals to from 0 t greater than a, t less than a, and 1 t greater than a. So a is equals to 3 pi, then h of t minus 3 pi is the Heaves side function. So from here f of t is equals to the Laplace inverse of f of s, and this, the Laplace inverse is sine 4t. So f of 4 minus 3 pi is equals to sine of 4 of t minus 3 pi. So putting this in the second equation, we get y is equals to 0 when t is less than 3 pi, and sine 4t minus 12 pi when it's t greater than 3 pi. So like this we get the function. And now for the part 3. So as we expected, we got the graph like this. It started from 0 to 3 pi nothing, and after 3 pi we got a sinusoidal graph. So as we can see, our graph is a sinusoidal varying function that states that t is equals to 3 pi. We saw in that y is equals to 0 and t is equals to, at 3 is equals to 3 pi, it's y is equals to sine 4t minus 12 pi after t is equals to 3 pi. So this is what we can see in the graph, comparing it to our graph we have estimated before. So we said that the graph may change its shape after t is equals to 3 pi, and the graph may or may not be present before t is equals to 3 pi.